This is the first video for Lesson 1 of Section 3 in Unit 5. We have now reached a point where many of the building blocks have been set, a foundation has been put in place, and we bring together ideas learned in previous lessons. In Lesson 1, our focus will be on the addition of mixed numbers. And in this video, we will revisit our models, the fraction circles or rectangles, the pattern blocks, and the fraction strips with a number line to help us visualize this process. And for all three models, we will examine those two types of questions again. Given the visual, determine the answer to a given addition calculation, and given the calculation, represented by modeling, to figure out the answer. As always, final answers, simplest form. So let's start with our fraction circles or rectangles. In example 1, we're going to use the model to determine the sum. Well, first we need to get the actual addition calculation. So I'm going to look at my diagram here, and on the left-hand side of my addition sign, I see two holes, and I see 1/4 of another hole shaded. On the right-hand side of my addition sign, I see one full circle shaded, and 5/12 of another. I need to combine all of this to get my sum. Well, I know that I definitely have at least 3 holes, but what happens when I combine the two partially shaded holes? And in order to do this, we again go back to the LCD idea. So for 4 and 12, my LCD is 12. I'm going to take the 1/4 circle, and I'm going to split that into 12ths. And there we go. And I see that 3/12, same thing as 1/4. They are equivalent fractions. And now I'm going to combine with the other partially shaded circle. So I'm going to take those 3/12, bump them over to the 5/12 circle. And when I do that, I can get my sum. We see that, yep, we do have 3 fully shaded circles. And now we have 8/12 of the 4th hole. So our sum of 2 1/4 plus 1 5/12 is 3 8/12. But is that simplest form? Not quite. The fraction piece, the proper fraction can reduce, and we get 3 2/3. In example 2, we're going to use modeling to actually calculate 1 5/6 plus 1 2/3. We're going to use some fraction rectangles this time. So for the 1 5/6, I'm going to put down one fully shaded rectangle and then 5/6 of another. For the 1 2/3, one fully shaded rectangle and 2/3 of another. I could, if I wanted to, take the first fully shaded rectangle, and I could split that into 6, and I could take the fully shaded rectangle here, and I could split that into thirds, as so, but it's not necessary. So we definitely have at least two holes. We need to combine together the two partially shaded rectangles again. So let's resort back to our LCD, and I see that my LCD for 6 and 3 is indeed 6. The 2/3 rectangle, I'm going to split that into 6. So now we need to combine our two partially shaded rectangles. So what I'm going to do here, I'm going to try and complete this partially shaded rectangle here. So I'm going to take one of those, 6, and pop it into the 5/6 rectangle. And in doing that, I get another hole. So what do we get now in total? 3 holes and 3/6 of another. 3/6, though, the proper fraction piece here, that can reduce. We know that will go to 1/2. So our final answer, 3 1/2. How about some pattern blocks? Use the model to determine the sum. On the left-hand side of my addition sign, I have 2 hexagons and a rhombus. That will translate into 2 holes and 1/3. What am I adding on? Well, I don't have a complete hexagon filled in over here, but that's okay. We can add mixed numbers and proper fractions. And the 5 triangles, well, that represents, as we know, 5, 6. So what we're adding here, 2 1/3 plus 5, 6. So I definitely know I'm going to have at least 2 holes in my answer. But how do I combine the 2 partially filled in hexagons? Well, what I'm going to do, I'm going to take my rhombus and I'm going to split it into 2 triangles. Then I'm going to take one of those triangles and I'm going to pop it over into the hexagon that already has 5 triangles. And what that does, it completes another hexagon. So that gives me 3 full hexagons and 1 triangle left over. So my sum, 3 and 1 6. So 2 1/3 plus 5 6 equals 3 and 1 6. Final answer. For our second example, let's use pattern blocks to add 1 2/3 plus 2 1/2. So to represent 1 2/3, I'm going to put down 1 hexagon and 2 rhombi. To represent the 2 1/2, I'm going to put down 2 hexagons and a trapezoid. Again, I definitely have at least 3 holes in my sum, but I need to combine the 2 partially filled in hexagons and see what we get. So I'm going to pop a rhombus over with the trapezoid. Still not a fully filled in hexagon, so let's go back to this guy. Let's split that rhombus into 2 triangles. Then I'm going to take one of those triangles, pop it in over with the trapezoid and the rhombus. That now completes that hexagon, and I'm left with 1 triangle. So I actually end up with 4 holes and 1 triangle. That would represent 4 and 1 6, simplest form. And last but not least, let's have a look at fraction strips in the number line. Here's our model. Okay, let's have a look here. Let's look at our fraction strips. So I see in the blue oval that we have a 1 whole and 2 1/5 strips. So in total, that'll give me 1 2/5. And what are we adding on? Well, in the orange oval, I have 1 whole and I have a 1/2 fraction strip. So what I'm actually adding together here, 1 2/5 plus 1 1/2. And I know, well, I'm starting at 0 and I'm ending off over here. So I know my final answer is in between 2 holes and 3 holes. And it's a lot closer to 3 holes, but I don't know exactly what my answer is yet. How do we get around that? Good old LCDs again. So if I look at my 5 and 2, my LCD for 5 and 2 is 10. So what my LCD tells me to do is to take this initial number line and split it into tenths. And if I do that, I will get this particular picture. And now, start at 0, I end off over here, and over here is actually 2 9/10. So when we add 1 2/5 plus 1 1/2, we get 2 9/10. And that is simplest form. So for our final example, we're going to calculate 1 5/12 plus 1 1/4 using our fraction strips and a number line. So I'm going to draw out a number line. I'm going to go from 0 to 3 holes. Hopefully that'll be enough. And we're going to put down 1 5/12. So we're going to put down fraction strips for 1 5/12. So 1 whole, 5 1/12 strips. And next to that, I'm going to place 1 whole and a quarter strip. I see I'm starting at 0 and I end off here, which is a game between 2 and 3. And it seems to be a bit more than halfway, but we want to figure out exactly what it is. What is the exact sum? So the decision comes, well, what do I split my number line up into? What types of equal sections? Where do we go for that? You got it. The LCD. And the LCD for 4 and 12 is 12. So I'm going to redraw my number line, put it in 12ths, put down my fraction strips again, begin at 0, end off here. Where is here? Well, that's at 2. So I got 2 wholes and 8/12 of another. Is 2 and 8/12 fully simplified? Not quite. 4 can go into 8 nicely, and 4 can go into 12 nicely, giving us 2 2/3. Now I would like you to proceed to the next video in this lesson.